Poker Calculator Part 1 right now on Blue Collar Coder. About a month back, I started playing with this casual poker app on my iPhone. And by poker, I mean Texas Hold'em, if you're familiar with that. This is me playing a bunch of hands so you can get a sense of what it looks like. You start at a table with 8 folks, and you want to be the last one standing. So I played a little bit, and I thought to myself, I'd really like to know the odds. So, let's make a poker calculator. It'll be easy. It'll be quick. I'll make a Blue Collar Coder video out of it. Well, 2 weeks later, and woof. Poker is deceptively complex. But it's done, and it's up on GitHub pages, so let's have a look. We have 2 aces and 8 players, including ourselves. At the flop, it's about 70% to win, and then it drops real quick as other players pick up more cards. Their hands can improve, and ours likely won't. I know this because I look over here at wins, and I see that I'm picking up maybe another pair or sometimes a full house. Whereas in the losses, I can see that I'm losing to straights and hands that can improve as more cards are drawn. I could also go over here and change the cards or the number of people and see what changes. So how does this work? Well, it works by running simulated tables, thousands of them, starting with your own hand and just playing until you have so many iterations that the odds just level out. And this app is what I'm going to talk about in this video because it's made in Vue and Typescript, and it's up on GitHub, and it's open source, so you can play around with it. So let's go have a look. Oh wait, one more thing. I do promise that at the end of this video, I'll give you some advice on how to do better at this game based on this calculator. So be sure to stick around for that. All right, this project is split into 2 big pieces. There is the calculator, which does the work of calculating one table. So given a starting 2-card hand and a number of players, the calculator will create a table, shuffle the cards, deal the hands, and then tell you who won. And then the UI part of the code, including the Vuex store, runs the calculator over and over and over again thousands of times to give you the overall statistics. So let's go into the calculator and have a look around because that's really a far more complex beastie than what you might imagine given what it's trying to do. Because all that's really happening here is you got a deck of cards, and then you draw the cards, and then you make hands. And then you compare those hands. Simple, right? That's what I thought. Well, let me tell you, trying to figure out from 7 cards what the best 5 cards are involves a ton of edge case work. Let's start over in card. This class represents a playing card. It's TypeScript. All the code is in TypeScript. It's got a suit and a rank, and whether it's used or not, and some accessors. The used flag we use later when we display it. It can be hard to look at 7 cards and immediately identify which 5 cards were used to make the best hand. So that's where used comes in. It shows you that this one has been used and this one hasn't. And these accessors just make it easy to do some simple comparisons between cards. The next logical thing to look at is deck. And that's what holds the cards. So up at the top, we have this FP Beauty. This is the code that creates a sorted 52-card deck by first iterating through all the suits and then all the ranks within each suit. And the deck class starts with that, but then it shuffles it by creating a copy of the deck where it adds a random value to each card and then sorts those values and then strips those values, those random values back out to give you just the sorted playing cards in a random order. Honestly, I'm sure there are better CS ways to do that, but this was the easiest thing I was able to come up with on short notice. After that, we have some simple helper methods to remove a card from the deck, to tell me whether I still have a card, and to draw a number of cards from the deck. Okay, so far we have a card, we have a deck of cards, and the next thing we need to do is model the different types of poker hands. That starts over here in hands, where we have an enum of the different types of hands. Now, if you're not familiar with poker, it's actually kind of fun to learn and to play, but I'm not going to go into too much detail here. Hopefully, some of these should be obvious, like pair, meaning that you have 2 cards of the same rank, like 2 aces or 2 5s. 2 pair means you have 2 pairs, and so on. It's the hand class that takes an array of 7 cards and then matches it to one of those ranked hands. And it does this by running a set of matcher methods. Starting with the best possible hand, and if it matches that, then it stops. And if it doesn't, then it continues all the way down to high card, where you always have a match because every hand has a high card. And there are 13 types of poker hands, and most of them have some sort of straight, so detecting a straight is still kind of tricky. The easiest way I could think of this is to sort all the cards by rank and then see if you have any continuous runs of 5 cards or more. And don't even get me started on the ace being both the low end and the high end card. Ugh. Now, sorting and searching is expensive. So what this class does is do all the work once in the constructor. It takes a given set of cards and figures out, do I have any straights? How many cards do I have in each suit? How many do I have of each rank? And so on. And that makes those matchers hyper efficient. The royal straight flush matcher just has to ask, 1, have I matched anything already? And I haven't. Is my high card an ace? Do I have just one suit? Is my straight also a flush? Meaning that I may have a straight, but are all the cards in that straight part of that flush? As I say, lots of edge cases. And then if so, I'll say I'm a straight flush. And then I'll do the second thing I'm responsible for as this class, which is marking those 5 cards that are involved in the hand as used. So first job, analyze the cards. Second job, match all the cards to a poker hand. Third job, mark all the cards as used. And fourth job of this class is to compare 2 hands and tell me which one is better. And that's over here in compare. So compare is interesting, but the story really starts over in the match result file, because that's where you have the class that stores the result of the hand matching. At the top, we have the rank, and that's the numeric index of the rank of the hand. 3 of a kind, maybe number 4, and 4 of a kind, maybe like 7. And then there is the ranks array that holds additional rank information that will help us in the comparison. Let's say your 2 top hands are both pairs of kings. So the rank of each other would be pair. And then the first number in the ranks array would be the number for the king. But because there are 3 cards left and a poker hand is 5 cards, we have the other 3 ranks as well that we also put into that array. That way we'll look at the other cards in the hand to see if we can resolve ties when we both say have a pair of kings. Woo, that's a lot of stuff to take care of. Anyway, having this object makes doing the compare really easy. First, let's look to see if one of the hands clearly has a higher or lower rank. And if they're the same, then we compare the ranks array to see if there are any higher cards amongst those extra cards. Okay, so I know this video has gone on too long. Let's just do one more class and we'll be done with this engine. The class I want to look at is table. It's quick. Let's have a look. It's just a container that holds all the hands at the poker table, as well as an indicator for who won overall and if we won after the flop and so on. The constructor is, again, where all the work happens. First, we shuffle the deck and take out our 2 known cards, and then we have 3 community cards. Then we draw our hand, and in the for loop, we draw the hands of all the players. Then we sort those hands based on compare. Now we know who won after the flop. And the final loop is what simulates the turn in the river. And it's the river that determines who actually won overall. In part 2, you'll see how we use this table in the Vuex store of the simulator. All right, as promised, what did I learn from making this thing? Well, at least in the context of this game, here's some advice for y'all. Survive until the final 3. That's where the money is. And to do that, fold all the time. I mean it. Fold any connector under an ace-king, and any pair under queen. Well, maybe even fold queens if there are a lot of callers. Then bet big and try to push everyone out. All you're trying to do here is get enough money to survive until the final 3 when things get interesting and you can play like normal. So does this work in real life? I don't know. I'm not a poker pro. In the meantime, thanks for watching all the way through. As always, please like or subscribe if you're so inclined. See you next time on Blue Collar Coder. Be kind to each other.